Welcome to another great Car Basic tutorial. This is a set of tutorials for the Logic Green Technologies LGT8XM chipset, and today I'll be looking at timer0 and looking at a thing called millis, which is counts milliseconds. So with more ado, let's get started. So this is part of a larger set of tutorials, and today we'll be doing sections 8 and 9. So what do these things look like? They are chips that you can get readily on the internet or direct from the supplier, and they look like standard little prototype boards, and I'll be using the green one, and I will be using later on in the tutorials a Uno, not an Uno, but it's a replica of an Uno. So this is the one I'm actually looking at, and we have added into the prototype board 4 LEDs via suitable resistors. We've added in a potentiometer and a switch. We added those in previous tutorials, so you'll have to go back to then. So what's important is that we've got this LGT's on a breadboard. I've pushed it into a breadboard, and this is the layout. And if I show you that layout, it looks like this. This is the actual one. It's actually operating. It's extremely similar. And I will then just show you very briefly the differences. The only difference between what Chris Roper in South Africa has given me is I've moved the resistor into this position where he shows it at the bottom, and that's the only change. The rest of it is in the same sort of position in terms of the layout. Oh, and I use a black switch, not a red one. Okay, but that's about the same. It's essentially the same. So what we're going to be doing is we'll be looking at a timer to flash these LEDs. It's actually doing it at the moment, and I'm showing you a timer to introduce the concept, and then we'll be looking at millis. So what are we actually going to be looking at here? Well, essentially what we're going to be doing is we're going to initialize this timer here, and then we're going to have a do loop that just goes on forever, and every time it goes through, it's going to check to see if the timer has overflowed, because when we start the timer here, it has a function. Every time it goes through 0 and it overflows, it sets a flag, and we can test for that flag. And if it has overflowed, then we're going to toggle our LEDs. And finally, every time that happens, we just need to clear down that overflow flag here. It's extremely simple, very simple piece of code, and I'll show you that it's pretty pointless as well. But it's a very good foundation for what we're going to be doing. Initialize, do the loop, check is overflowed here, and then just walk through, clear those flag, and carry on. So let's have a look at the actual program we're going to be working with. This is it. You've shown you the introduction to this many times before. I've set the chip. I've set the option explicit. I've set the LEDs to outputs so that they will flash when I change the signal. Now, for those of us eagle-eyed, I've set the frequency to 0.125. I've done that because that's important that we can actually see the LEDs flashing. So to initialize. The initialization is very simple. We're going to initialize timer 0, and we're going to use the internal oscillator, and we're going to have a post scaler of 64. So every 64 clock cycles, it will increment, and that post scaler will then sets the timing. So if I set that to a post scaler of 1, it would overflow quite rapidly. So I just need to scale that back. So the post scaler is a scaler of timer 0. Then I need to start the timer. And then this is my test, this is my do loop here, and finally my test. And I say, if timer 0 has overflowed, and that's this TOV here, timer 0, there's another one for timer 1, etc. If it's equal to 1, then toggle the LEDs and clear that flag. And you must clear the flag by setting it to 1. And that's in the data sheet, but I'm showing you here. So if I just program that up, we'll see that the LEDs will flash, and they're flashing at a steady rate. If I change the postscript to 128, which is twice the post scaler that it was on the previous run, you'll see that it complains. Oh, what have I done wrong there? Let me look at the help. Oh yes, that's right. The correct one will be 256. Okay, I'll just change that to 256, and we expect to see the LEDs flash at a slower rate. Now that's about the only level of control you've got. So timer 0 is running in the background when this is all happening. So if I just change the frequency of the chip, you will see that now that the timer 0 is running faster, the LEDs are flashing faster. Hence I had to slow it down so that you could see this. So very little, so you can use timer 0, timer 1, timer 2, timer 3 in the same manner. Initialize it, pick your clock source and a scaler, and then you need to start it. For if I don't start it, if I reprogram that with the starter missing, the clock is not running. This is important. So I need to start the timer. Once I've started the timer, it is now free running in the background. These flags, TOV, 0, 1, 2, and 3 are shown in the data sheet, but this is a way of really simply setting an event to happen on a particular timer. But that's not overly useful, and I'm going to show you how to use millis in Great Cat Basic with this chip. Let's go back to PowerPoint. Now I'm going to use a function called millis. Actually, it also happens to be written by Chris Roper in South Africa about 2 years ago, and we're going to insert this into our program. Pretty simple layout. We're going to initialize the millis at the top here. Then we're going to have our standard do loop where we could do other stuff. And essentially what I'm going to do is I'm going to look at the current time called millis, and I'm going to put that in a variable. And if if a specific time or specified time has been exceeded, then it will toggle the LEDs and it will save that last time that it did it. And then it will carry on around the loop. So it's going to save the time here, do a test, and if that time period has been exceeded, then toggle the LEDs. And this is very different from the wait that we've seen before, because I can do lots of other stuff whilst this millis is running in the background. Millis is very, very familiar to Arduino users, but I'm just going to show you that you can do some other stuff inside of Great Cat Basic. So I'm just going to change the program. I'll just run it and compile it just to show you that it's actually running. And it's currently set to 1000 milliseconds. The program. I can set it to any frequency that's divisible by 4, so 4, 8, 16, 32. I don't think you can do that on Arduino, so somehow help you understand that. I've got this set to, I'll set it to 32 so that you can see it works still. LEDs are all set up the same, and then I include the library called millis. So hash include will now pull in the libraries called millis.h, and it will then insert that into my source program, and that exposes the function called millis. I set a constant called LED rate of 1000, and that's my time to exceed. The moment it exceeds 1000, it's going to flash those LEDs. Declare some variables and define those as 0, because that's my starting point. And from memory, I think this you'll run out of, millis will count for several months before it overflows itself. Now, here's our do loop that we've seen here, starts here, ends there. And essentially what I'm doing, here's the millis function. It says, put the value of the current millis into cur milliseconds. So that's been shortened down to CURMS, current milliseconds. And here's our if statement, very simple. It says if the current milliseconds is minus the last milliseconds is greater than our LED rate. So the current millisecond was here. Initially, the last milliseconds is 0. So the moment that cur milliseconds is greater than 1000, it will then flash our LEDs. And then we save and record the time. So that last millisecond, or LSTMS, is then saved and cached. So if I change the value here to half a second, which is 500 milliseconds, we will see the according pulse change on our LEDs to every half a second. If I change it to 250, quarter of a second, you'll see that the LEDs pulse a lot faster. So what we've now got is control of events. So we can have use timer 0 in the background, because millis sets timer 0 running for you. It's actually set it all up correctly. You can change the frequency of the chip. I've changed it to 4, and that will still flash at quarter of a millisecond. So that's all been looked after inside of this library that we included here. So millis is extremely useful if you want to time something, if you want to see how long a program is running or a section of your code is running. You can save the current milliseconds and then do a compare the same calculation. It's extremely powerful for controlling your own weight. So rather than use the weight function that's inside of Great Cow Basic, you could write your own that uses timer 0. Now this is using the internal clock inside of the chip here, but you could use the external as well, but it would have to be divisible by 4. If I try to set the frequency to 1, it flashes, so it's clearly still working. Let me just try it down at 0.5. Oh, Chris is quite clever. There you go. It's too slow. So it works down to 1 megahertz, and that's it. So if I just take that off and put that back to 1, so I'm using low power in the chip, but millis is still running in the background. So what I wanted to show you was millis, that you can use timer 0 with a great amount of flexibility, and you can control millis in your own program. Back to PowerPoint. So that's what I wanted to show you. Enjoy.